Wow, you are in for a treat on this week's Swarf and Chips. We have flown all the way over to Stuttgart and spent 2 days at Paul Horn's international headquarters.
You want to be excited for this one, sit back and relax. This is a cutting tool extravaganza.
So we are here in the heat in Tübingen, and I'm here with Mike Green, who's the General Manager from the UK. Mike, tell us about the company. What are you all about?
We are a company that's grown very quickly in the industry. We manufacture precision ground grooving tools, cutting tools, and we pride ourselves on a very technically able sales force and a very strong support team here back here in Germany.
And you said predominantly grooving. Is that the only tooling that you do?
No. We've diversified into other areas, mainly because of the customer's request. But we now do milling, general milling tools, not ISO, but face milling, long edge milling, helical milling, and a massive range of groove milling.
So Paul Horn class themselves as world market leaders. How can they give themselves this title?
It's mainly because of the strong technical backup throughout the company in individual countries and so on. And also the product range is we have far more products for predominantly grooving than any other competitor in the marketplace.
We're at the beginning of the tour, so where are we, Alex?
Right now we are in Horn Hardstoffe, and this is where we produce our carbide blanks and carbide powder.
So there's different processes going on here. Talk me through these.
There's many different processes here. If we go from the beginning, we take carbide powder among many other additives, mix it under high temperature, which is then chopped into pellets that can be used for both our injection moulding and extrusion processes. However, behind me we have some powder which is used for the powder presses. Feel the weight of this.
Wow.
It's heavy, right?
Right, that's about, I'd say about half a bag of apples or something that day. I did not expect that to happen. Why is this? Why is it so dense? It's a dense material.
Well, this is tungsten carbide powder, and as you say, it is very dense and it is very heavy. I couldn't say specifically how many apples though, unfortunately. We also have some blanks here as well. This blank here you can see is pre-sintering. That's why it's so much bigger, and this is post-sintering. During the sintering process, we expect to see around a 20% reduction in size.
So talk us through the sintering process. What is that?
Okay, well, there's 2 steps to the sintering process. There's pre-sintering and then sintering. It is essentially loading the blanks as they come off the powder press into an oven for around 8 hours, about 1200 degrees. And during that time, the shrinkage occurs. And
why do you need that shrinkage? Does it strengthen the product?
It's not a necessity that we need it. It's just a process that happens when the material is kept at heat for a long period of time.
And so you've got state-of-the-art machines behind us here. You're making a very, very high-end product. You've got to use quality machines, right?
Yeah, you have to have state-of-the-art machinery. I mean, as you said, this is the first stage, and it's fundamental that we regulate the process from start to finish to get the best possible product.
All for quality control.
Of course, everything has to be controlled at every stage. Inspection is one of our top priorities, and it obviously shows because we produce quality cutting tools.
Would you believe that tungsten carbide pre-sintered is one of the hardest substances on Earth? That would make me Mike Tyson, but post-sintering, yeah, not a chance. Alex, there's over 100 machines behind you and it looks quite busy. What's going on in here?
Well, this is our main grinding facility where we produce our inserts. A range of tooling from groove milling through to super mini.
Are they bespoke machines?
The machines have been adapted to better suit the processes with automatic handling, loading the inserts into the machines, which enables an operator to run several machines at one time.
A nice speciality for Horn.
Certainly, yes. It is an advantage.
Now, we know that inserts fit the bill, but these are the holders. Do these compromise the end part in any way in the machine?
Yes, certainly. The whole interface is fundamental. So the grinding of the insert and especially the location of the insert into the tool holder to ensure we can machine components with the utmost accuracy.
So are you telling me that you make all of your holders on site here?
Yes, certainly. All tool holders manufactured for Horn products are manufactured internally here by Horn.
And these are quite technical now. Are they all one-hit machining? I mean, just look at these machines. They're state of the art, aren't they?
No, we do aim to get finished product off the machines in as few processes as possible when it is achievable.
And so are you telling me that you will make the holder, you make the insert, then do you use these back on the machine?
Yeah, I mean, in a lot of cases we do. As I say, we grind the inserts, we then manufacture the tool holder, we could then load it into the machine and manufacture more tool holders with it. So yeah, it's a wonderful process.
It's fascinating.
Always new products being launched by Horn. Tell us what we have here, Philip.
Okay, here we have two things. One is a new geometry made for titanium, and the other thing is a sensor to measure the wear on the insert.
So let's start with what it does. What are we actually showing here?
Here we show a geometry for titanium. Titanium has the properties that you have build-up edge on the insert, and here we have a special coating in combination with the special geometry to work against this build-up edge, for example.
Okay, what about the tracking data element here? Because that's critical, isn't it?
Yeah, that's really critical. Often when you have critical applications on the machine, it's always hard to say what is the tool life of the insert and when you have to change the insert. With this tool, it should give you the possibility to change the insert due to
because the data is being fed back into the software, so you can monitor.
Yeah, you can monitor the process, and then when you monitor the process, you can say when you see the data when you have to change the insert.
Does this mean though that every tool has to have this, let's say this wire or this transmission element on it as well, though, when you're putting it in the machine?
I mean, that's not clear at the moment. So we want to show here together with company Kista what opportunities you have with this kind of sensor, that you can measure the wear on the insert. I mean, this is brand new for everybody. So here we want to see what is needed on the market and what can we do with this kind of sensor.
Always my highlight when I come to events like this is actually seeing the machines in action and the cutting tools in action. Impressive demonstration here, Alex. Tell us about the tools we're using.
We're using quite a few of our tools here actually, starting with the high feed milling cutter for fast metal removal rates. We're also using a tangential milling system and some of our solid carbide end mills.
Tell us about some of the speeds we're moving at as well and feed rates.
Talking in respect of the high feed milling cutters, they're using speeds of around 200 metres a minute and 0.8 feed per tooth.
Do you find your customers experience very, very minimal tool wear using your tools? Is that one of the big advantages?
Certainly tool wear is a big factor in the tool life and how many components or the amount of metal you can remove per edge. The benefit of having these machines here is we can run trials and tests of these products and set benchmarks or get rough estimates as to tool life.
So Alex, this is the tech centre. What's it used for?
A number of things actually. First and foremost, we trial new products here that come from research and development so we can apply them to certain components and see how they perform.
So it's benefiting Horn, but what about the customer? What can they use it for?
Benefits both Horn and the customer. In some cases, if a customer has a difficult application, we can bring them in and show them how to best apply the products to achieve what they want.
Really trendy topic at the moment. We're hearing a lot about gear skiving, and you're showing that here as well. Tell us a little bit about this process and the detail of this demonstration.
It is one of the newer processes which Horn is getting involved in, the gear skiving, and having machines such as the one behind us here allow us to explore and demonstrate those techniques.
Yeah, I think a lot of it is in the machine tool, isn't it? The clever technology behind the software to make it happen. But how important is the cutting tool, the insert and everything that you have on that side to support it?
Yes, certainly. I mean, the accuracy of the cutting tool is fundamental in the operation of the process. Now, we can perform both internal and external gear tooth machining. What we rely on as much as a precise cutting tool is a perfectly synchronized spindle in terms of the comparison of rotation of the tool and the machine spindle.
This opens up an opportunity for engineers, doesn't it, to change the way they think, to do things differently, potentially more efficiently.
Yes, certainly. I mean, until the introduction of this gear skiving method by Horn, typically you might have to broach internally. Some external gears you can mill, but this really opens up possibilities to machine gear forms more quickly.
Certainly very popular here this week anyway, isn't it?
Yes, certainly. This looks like one of the main attractions, shall we say.
I found something really out of this world. It is an alien and is hanging around by his spaceship. Hiya, Paul. How you doing?
Yeah, right. Yeah, good. What an incredible machine this is. Have you seen this? Check this out. Now, what they're doing here as well on these technology days is they've introduced several partners are here showing off machines and their solutions, and one of which I found here. It's incredible. This is actually making this component out of this billet here. Now, there's loads of features on this part, as you'll see, and it's actually out of a Mercedes, something to do with a gearbox, I believe. But our cycle time challenge this week is actually to find out, we want to know how fast you think this part is made complete. Now, the idea behind this machine is you've got 12 stations, essentially, 12 spindles here, and each spindle has got up to a maximum of 6 tools. So each spindle could have kind of 6 operations being done at once. But the idea is that you obviously, like a multi-spindle machine, you try and balance out each spindle so that once this op's finished, the next op's finished, and every time it rotates, you get a finished component. So essentially you're doing 12 operations at one hit, and this particular part is the one being made on here. And this is our cycle time challenge for this week. And I bet I'd be amazed if anyone got the correct answer, because it is incredibly quick.
Yeah, all on a Pifner machine.
Beg your pardon? So the final part of the process happens here. Alex, thanks for joining me. Just tell us what is happening in this department.
So, as you said, this is the final part of the process, and this is our in-house coating department. The main benefits of this is that we can control and improve the coating process and develop our own coatings in-house.
How important would you say the coatings are in the whole makeup of a tool? Is it the most integral part?
I mean, perhaps not the most integral, but it certainly offers many benefits depending on what material you're machining. As you can see behind you, we've got our new EG35, EG55 coating, and this has been applied to the Super Mini range, much sharper edge, improved tool life, so yeah, there are many benefits.
And how long would it take to coat the amount of tools that you've got in there now?
I believe they go in for about 8 hours, so it's an 8-hour cycle time under high temperature, high pressure environment.
And giving yourselves the edge, you must be continually developing new coatings. It must be one of the most heaviest parts of the research and development, is it?
Yeah, as I say, it's very technical, it's very advanced, but constantly developing allows us to have a cutting edge within the marketplace. We can offer the best solutions possible, and we're always striving to move forward.
Now, I said it was the final process. I think there is one more. In fact, Lindsay's looking at it now. And in fact, Lindsay, for you, that looks like a bit like a tanning machine as well. So I think you're off on your holidays, because I think you're on your way to the airport.
No, Paul, this is not airport security, and this is real. Thank you very much if you've seen the weather. No, but in all honesty, this is their automated packing facility where all of the finished products get put into these boxes and sent out. I mean, what a facility. Thank you for watching this week's Swarf and Chips, and a massive thank you to Paul Horn for their hospitality. You too can have Swarf and Chips filmed at your premises. Do contact us on swarfandchips.tv. Don't forget to like, comment and subscribe. And as we always say,
Lass die Spindeln laufen.
We're done recording. Have a beer.
Fast, we'll get that one.
Is that it?
We appear to be waiting for one more, just one more. One more person, we've been waiting 10 minutes. Yes, the Swarf Guru.
Come when you can. When you're ready.